Links. Available options are call, dial, redial, pair device, transfer call, phone book, voice training, play, exit playlist, or setup. Available options are call, dial, redial, pair device, transfer call, phone book, voice.
Or Alaska, these are the high seismic states in the United States, to adopt this technology and expedite bridge construction.
Well, I want to talk a little bit about the experiment itself, because it is, in terms of a magnitude, massive. I mean, this is a 70-foot long piece, 100 tons. How in the world did you get this into the lab, or I guess, how was it built? What went into constructing this?
Well, first of all, this was 2 years in the works.
Okay.
From the design until we got to the point that we detailed it and started building the pieces. So the pieces were built differently at different times. The footing, the columns themselves consisted of 2 pieces each. The beam itself, the girders, the deck elements, these are all built separately. The girders, for example, they're highly specialized. They're pre-tensioned, and there are no fabrication yards in Nevada to build them. So we have to get them built in the San Francisco Bay Area and shipped to us. All the other elements were built by local contractors here in Reno, and then everything was assembled, and we had on top of that we have more than 400 channels of data. So we had wires coming from all over the bridge to collect the data during that seismic event.
We're talking with Professor Saeed Saidi of UNR's Earthquake Engineering Lab, where they just completed a one-of-a-kind experiment involving a 100-ton, 70-foot bridge segment. Professor Saidi, so the bridge gets built, then what did you do to simulate a 7.5 magnitude earthquake?
We have a state-of-the-art shake table facilities at the University of Nevada, Reno. Our shake table laboratory has 4 shake tables, and this is the largest facility in the U.S. with 4 shake tables. We have sophisticated controller systems that can simulate just about any earthquake. So at the base of the bridge, we had those earthquakes simulated. In this particular case, we used a Northridge record that was collected in 1994, earthquake in Southern California. And we can manipulate this earthquake record by de-amplifying or increasing its intensity. And we typically do that until there is some failure or there is so much movement of the bridge that further testing is no longer safe.
So I guess this is the million or billion-dollar question, and one that might one day save lives. What exactly did you learn from the experiment?
What we learned is that all the 6 types of connections that we incorporated, they generally did well. We have a target location for the damage under a very strong earthquake, and that target location was indeed realized. In other words, we did see the damage at the columns, which is where we expect them to happen. That means that that means the connections worked well as intended, and shifted the damage to structural fuses that were predetermined. So it was very successful. However, as I mentioned, we had over 400 channels of data that we have collected. So we are looking at that data, and it's going to take many months to look at the details of what happened inside these connections. And just from preliminary checking during the test, I could tell that there was some fine-tuning is necessary in some of these connections. So the outcome of this test will be that, okay, now we have confidence in these connections, but there has to be some tweaking of some of the details in terms of the amount of steel we put in the connection and the kind of detail we provide.
So this type of bridge seems to hold up well, relatively well, in a 7.5 earthquake. Are these sort of bridges out there right now? Are there a lot of them in the country or in the United States?
None in high seismic zones. And that's really the point of our research. This project was funded by the California Department of Transportation. High seismic states such as California, Nevada, Washington, Alaska have been slow in adopting this technology of prefabricated elements because of the concern about the connections. Now, based on our research, Caltrans has started 10 pilot bridges, but they also funded this bridge and one other bridge test that we're going to do early 2018 to have confidence. Okay, once we see that these connections indeed work, then there's going to be a widespread application in high seismic states.
Is Nevada considered in any way a high seismic state? We seem to get, from things I've seen online, like hundreds of little tremors. Should we worry in the state?
In terms of level of seismicity, Nevada is number 3 in the country, right after California and Alaska. Indeed, we have had very strong earthquakes in northern California, in northern Nevada. So there is historical data that shows, yes, we are susceptible to earthquakes, so we are considered to be a high seismic state.
Is it true? I've heard this almost since when I moved here 20 years ago, that there's a fault line that goes relatively sort of down the middle of the Las Vegas Strip.
I guess you could call Nevada the land of many faults. Many of these faults are inactive, but indeed there are faults that go through Vegas, and the general direction of these faults are basically north-south, but you have many of them parallel to each other.
And we do get a lot of these little tremors, as you said. Like I said, you can go online and see them almost daily, hundreds of them that are measured.
Yes, correct.
Do those little tremors save us in any way? Because they maybe are releasing little bits of pressure instead of saving it up for one big earthquake.
That's certainly the general thinking among the seismologists who study the nature of earthquakes themselves. Our focus, of course, is on structural engineering, meaning that to build bridges and buildings so that they don't fall apart regardless of the intensity of the earthquake. But the seismologists generally feel that these little tremors release the pressure, as you mentioned.
So what's next at your lab? What are you working on?
There are actually 2 more bridges that we are right now under construction that will be tested. One is through a project funded by the U.S. Department of Transportation, and the one after that will be again another project funded by the California Department of Transportation. Another project we are working on involves developing seismic design guidelines so that national codes can accept those eventually. That way we facilitate the application of these prefabricated bridge components for what we call ABC, which stands for Accelerated Bridge Construction. So that's another project that's funded by the Transportation Research Board and the NCHRP arm of that